because talking about the disasters, like it's very hard to imagine what kind of a disaster in the software world. It's like, you know, having an unhandled 500 on your API, or what really makes a disaster?
What's really makes a disaster? Well, disaster have like a lot of different flavors, and like when you're speaking about like a large system, it can start from like your data center is going down and someone put it on fire, and you would be surprised that it's not very rare thing. I think.
How frequent does it happen?
I don't have statistics, but I think like once a quarter ish. And maybe if I will,
once a quarter in the world, or per provider?
in the world. Yeah, it's actually an interesting question. It's probably if you'll collect statistics across like multiple service provider, I bet it would be even more often what's called thermal event. So
thermal event.
We don't call it like data center got on fire. We call it thermal event. Because what? Because it's happened every month. And when it's every quarter, it's not longer like something unexpected. It's like, yeah, it's disaster. Like your system going into some mode which it's not supposed to work on. Yeah, like service doesn't supposed to work on like 100 degrees temperature, but it's not longer surprise. It's business.
It's like it's like our server is hot. Like what? Pick lots? No, it's fucking fire.
it's on fire. Yeah, it's remind me actually. It was while back ago, and yeah, I had my data center almost on fire. Like in reality, it's like air conditioning was down in the system because you know what, like inflow of air conditioning system was dumped with something, and
what?
yeah, and how it was called, you know, in there is like some kind of trees which produce a lot of like
Pollen.
Pollen, not a pollen, it's more like damp substance, and it's fit everywhere, and it's like clogged inflow of air conditioning system, and air conditioning system like slowly get down, and temperature of whole like center like slowly start getting up. So basically at the point when I arrived to the scene and like I touched the handle of a door, it was like damn hot. And how we know about it? Yeah, because one of the servers said, you know what's like, it's too hot here, I'm going to sleep. And we're like, hey, server, go to sleep with like very unexpected event, like how it's happened. So yeah, that's how like 15 years ago I was introduced to. And you know what? Like I start monitoring server's temperature since then. It's become less important with AWS when you hosting something on it, but when you owning your own hardware, yeah, it's like lot of our mistakes is happened because of experience.
Okay.
So they like we called it, you said it like saw some shit. We called it experience nowadays.
Experience, yeah. You see my white hair, right? It's experience.
Yeah. I also have a couple of here. So yeah, it's like each of them is like literally very good and very entertaining experience.
Okay, experience. Yeah, I see you have a slide number 3 with your rocket blowing up. Like, what's the story about?
That's actually a story which I wanted to start with, and actually that's the story which I telling like a lot of my teams periodically as a reminder about disasters. So Challenger 1986, it was a year when I was born. But story not getting old. So in January, space shuttle exploded after lifting off, and unfortunately killed 7 astronauts. So like that's definitely was disaster, but it doesn't had like any recovery in it. And why this story is very interesting, because like in case of Challenger, explosion was like very known fault of the filler on like O-rings on rocket boosters. So basically like everyone knows then they faulty. But during launches before, like nothing happened. And you're launching one rocket, nothing happened. You're launching another rocket, nothing happened. You're launching third rocket, nothing happened. You're like, it's probably fine.
Not a problem.
It's not a problem. Yeah, it's like it's faulty bit, and I think it's basically story of my life when it's come to operation management. It's called like it's fine until it's not fine. And with Challenger, it was exactly the same. So the same faulty filler leaked again, like gases burned through O-rings and ignite main fuel tank. And like, can it be prevented? Yeah. After this story, NASA like introduced a huge program of like disasters prevention, how they managing risk, how they like dealing with it. And Professor Dan Wayne come up with a phrase called normalization of deviance. And basically it's very interesting book about challenging launch decisions. So risk technology culture, I definitely would recommend to read this book because again, like it's 1986, but I'm looking how people making decisions right now and how they managing risk, and nothing mainly changed since NASA. But story is very simple. We as humans, we like think about stuff like, hey, if it's happened, if not, like everyone, I bet like most of us who's on this call, like guilty of speeding, and until you get in the ticket, but nothing happened. I increased my speed for like 10, 20, nothing bad happened. Probably I can do it again. And you're doing it again, nothing bad happened. I'm like, okay, probably I can do it like systematically. And it's going fine until, until it's not fine. So basically this usually normalizing behavioral, which is should not be done like this because get feedback loop. Like it's not painful enough for us. So that's that's the normalization of deviance, and I think that's one is, from my perspective, one of the biggest reasons for most of disasters. So we usually know about the issue, we like deliberately ignoring it, and when it's happened, people like, oh, how's it happen? Like, why it's happened like this? And like, well, what did you expect it? You know about consequences. The fact that like probability of these consequences is low doesn't mean it will not come to you. And I have another interesting talk with about one of my friends who like worked in Netflix, and we figure out that like we have like 3 levels of way how we feel about disasters. And first level, which like a lot of companies are starting with, and basically like they believe in it to some extent, that disaster will not happen if I'm doing right things. But basically putting the measures, we like assessing risk, we know about our risks, we know about everything, like shit will not happen, which is true for quite a long time. Like you growing, things going fine, you continue doing what you're doing, things going fine, you start doing more risky decisions, things going fine. So yeah, our disaster prevention plans working.
Oh yeah, so it's basically humans do not understand statistics, right? So
nobody understands statistics.
Yeah, it's like the probability of the disaster is like 3%. Oh well, it's very low. So we're like operating for a couple of years, but then the time comes and this 3% becomes like eventually 100%, and the disaster still happens.
No, I think like 3% is still like the same percentage, but it's compounding with something else. Like my favorite story about this is like safety in aviation, and you usually like in aviation, like probability of particular events like relatively low, but when they get in together, you get in disaster, and that's basically what's usually happening, that they multiply on each other. So if let's say on your plane one things get faulty, yeah, it's fine. Like you can get back to another airport, we can do a lot of stuff. Plane have like long flying altitude actually to like just go to somewhere. That's actually a very good reason, and we can talk about it. It's very good reason why, for example, flight from New York to Europe, it's not going like straight through the ocean. It's going through like Canada, it's going through a lot of land, and there is a rule that you should have like 2 hours flight time to any land. So because of what? Because if plane got faulty, you can like slide to the nearest land and not in the middle of Pacific Ocean.
Oh, okay. That's interesting fact. I didn't know that.
Yeah, and basically it's getting us to like how you deal with disasters. Sometimes like thinking about how to avoid it, it's the best thing to do this. But why it's important? Because sometimes people doing wrong things. And for example, like half of the measures, even with the plane, depends on the amount of fuel it's have. And I heard the stories that people like, oh, actually, we may not have enough fuel to get to our destination, but we'll try to reach it. That's very common story with like small aviation. People are like, yeah, it's like, it will be tough, but we'll get there. Now what? Yeah, not everyone gets there.
Yeah.
But it may not be a problem if it's, let's say, fuel alone. But when it's fuel and something gets faulty, or you get like some unexpected weather, then you get in trouble. And that's usually how most of disasters in like our software system happens, because it's not just like one thing. It's a couple of things arrive at the same time and arrived in like
it's like perfect storm.
It's called perfect storm, but yeah, I like this calendar about slug disasters, and you can see basically like it's visual. Especially December 2021 was pretty bad for them. You know what? Because AWS was down, but like AWS was down and it's impacted them. But later they impacted themselves because they tried to recover from AWS was down. And they make another trouble for themselves. So yeah, that's
yeah, it's like if you if you read the postmortems of big companies like Slack, Netflix, I don't know, any other, you name it, you will find out that like it's not only a single problem with the database or monitoring or whatever. It's like several problems. It's like unusual conditions. Then they unveil the bug into underlying systems, and like combining those factors that just let all the system down. And yeah, that's interesting.
Yeah, where I had this face. I lost the slide. Whatever. It's was fun joke of one person who's like, oh yeah, last week we like fixed bug in production, which was here since 2018. So basically, like 4 years, some bug was in the system, and yeah, it was fine because it was like relatively low load. Then you getting higher load and some component getting down, and because this component getting down, like half of the system getting down, and you getting very surprised by like, hey, actually this one down, it's not a big deal. That apparently not.
Okay. Do you know this term called metastable failure?
No, actually, what it is?
Yeah, that's an interesting thing. That it's like one thing going wrong. It causes all the downstream systems behave wrongly, and it maintains in this state. So like it's not sufficient to just restart the faulty system because all the system is already in the failure state, and you need to redo everything. That's why you can have like 3 days outages when you just, it's like not sufficient to just restart one service. You need to restart everything basically. So yeah,
that was the story about, I think, first time S3 when it was restarted after first fault, and it was 2009 if I remember correctly. Yeah, it's took them a day to restart all components one by one in very manual mode, because yeah, guess what, some of them depends on each other, and because of that AWS also have like several programs which preventing like circle dependencies in the services, because it's like if you have like very strong circle dependency between your services, like this system usually beyond recovery point if some of them is going down, and it would took you like very significant amount of time to fix it, and I think a lot of people not even realized it until they face it first time. And let's be fair, it's also hard to spot it in a system without like specialized software, without special like looking for it explicitly. I think like it was Meta who was down last year or year before, when they had like literally two systems which was interdependent on each other. One system was like stored keys, and another system needed these keys to like start up. And this system also needed some credentials or something from this system. So basically, like you cannot turn them down, boss, and start them up, boss. And that's exactly that's exactly was time when they access to the building was dependent on the IT system. So people was not able to get into the building because guess what? Authorization is down, and if authorization is down, like your physical access to your data center is also prevented.
You can't get in the room to fix the
problem. I think on this day Meta was like, that's close to like complete disaster as like challenger type of disaster. What saved them, that's basically one of the system had like manual override mode when you get in USB key, put it into real like server, and then system, instead of like going to another one for this key, is like get it from USB and start up. So some smart person like 20 years ago, and I think like half of the company should be grateful for this person, think about it. They're like, hey, what will happen if like my system doesn't have access to anything else? And like, okay, let's just get this override mode so it can start up without dependency. But
indeed, a very smart person.
It's require a good level of paranoia and some of experience, because
experience.
Yes, it's need some of experience so you can think about it. I think like most of risk management practices, and like we're talking about disaster recovery, but in reality, disaster recovery, it's like last resort. You already like everything going not as planned, and you need to get out of it. But what's really helps there to plan how you will get out of disaster recovery, out of disaster. And let's get us back to the story about like 3 different levels of feelings about disaster. So first level, like disaster will not happen. And it's
wait a second. Let's turn down the presentation for a moment, so like the people can enjoy your beautiful background.
Beautiful background is good. I also find out improper t-shirt today, so it's like
Doppler effect.
yeah, it's exactly Doppler effect here. So sorry about that. So first level, disaster will not happen. That's pretty normal. I think most of us was in this condition for a long time. I probably lived in this condition for first like 4 years of my career.
It's like system administrators divide into two groups, right? The ones who make backups and who already make backups.
Yeah. One who like don't think about backups, and one who's like already making backups. Yeah, exactly. And it's not only about backups; it's about lot of things. And I think like your list of stuff which you need to do is like growing over time. Backups, network, like who is the best friend and best enemy of any software engineer?
Themselves.
Yeah, it's actually this one is first, but second one is electrician guy. Because they definitely would like switch off something exactly in a moment when you don't expect it. And
I thought a guy on a truck who can dig deep the earth and the cables.
That's the third one. They usually like killing network between like continents. That's also happened probably once, twice a year.
Yeah, I remember a story of some bank that had one internet connection going to their data center, and they had a reserve one, but guess what? It was right next to the first one. So a single dip into the earth, and they're offline.
Yeah. Actually, that's how most of disaster recovery plans happen in place, because people are like, oh, we need to have like 2 lines. Yeah, sure, we have 2 lines. Like, where these 2 lines is located? Actually, yeah, people say like, oh, we need to have like 2 data centers to be like prevented from issues. But guess what? Where's these 2 data centers located? I have a people who like for real said me like, yeah, we have 2 data centers, everything will be fine. And I'm like, can you show me on the map where these data centers located? And they're like, 2 data centers from 2 different providers. I'm like, okay, show me on the map. Because unfortunately I knew the answer. And they showed me on the map and like these 2 data centers like almost cross the road. And like they sit on the same electricity lines, they sit on like a lot of stuff. And like, do you understand that like anything happen in this zone from multiple standpoints, like both of them going down?
Yeah, electricity, fires, flood, storm, like
they're like, yeah, we did not thought about it. And yeah, I think like I can speculate, but even for AWS, current availability zone is like distributed in geographical space, still having like direct connection between them, but like very well distributed because of exactly this story. So people
speaking about availability zones, so like how much geo distributed they are? Is it like the different ends of the same city, or like it's the whole area of the country and they're spotted in different states, for example? Or
I think it's closer to, well, first of all, when you come into this position where you like have tons of trade-offs, what you need to think about it. For example, like having like several availability zones in Texas in different parts of city or even states doesn't help. Because like if Texas electricity grid going down, it's going down like completely.
Does it go like for the whole state? It can go down?
I think last time when it went down like for like whole state.
For the whole state? That's crazy. Like I can imagine one city going out, but the whole state, it's like it's huge.
They think about, and yeah, that's something like when your level of paranoia is kicking off, you start thinking about it. Basically, how they interconnected, how Texas as a state interconnected with others. And you will find out that Texas is like a bit special because I think there's a couple of states like this, but majority of grid in US is like interconnected, more or less. So if basically somewhere you have a surge of electricity consumption, you can get extra capacity from other places. But Texas is like a bit unique. It's not fully interconnected. It's have like out into like big grid, but not like proper one. So it's like if something going in Texas and when it was like huge snowstorm there and electricity consumption kick up, yeah, that's like whole system get down. And the thing here, you sometimes surprisingly, you never will sometimes understand all this interconnection. I feel like COVID show us how whole world is fragile from this perspective, because like supply chains all depends on one small canal in somewhere. And if someone's stuck in it, you're like disaster. Like that doesn't remind you anything about software system? Like this small queue which is processing something, and usually it was working fine for decade.
It's like we have a very small server that's serving like 3 key values, but they are critical to starting all the services, and you're like, oh, we're screwed now.
Exactly. And I think like that type of disasters, it's, if I will pick one of biggest type of challenges which I saw for large system, that's exactly where like you have like huge fleet of machines, which is depends on like small fleet of something which is usually like low traffic and low load, and it's working fine. You have like thousands of something which is looking on 10 machines which is serving like some key value, and it's okay until this big fleet doesn't kick off on a load, and or maybe someone introduce a bug, and then instead of like making one request to this like small fleet system, it start making 10 requests. And guess what? Like small fleet is syncing down, big fleet syncing down next to it.
Yeah. We're thinking like, what are you thinking about? So here's my question, But you can just have like every component of your system be scaled up and consider any amount of load for every component in your system. You have to have some trade-off, right? So you have to make a decision that, hey, like looks like this setup is okay-ish for us, because you don't want to spend like a lot of money to make everything resilient. It doesn't make a lot of sense. And the problem here is that you don't know in advance what's gonna go down in case of super crazy load or a disaster. So how the architects and like staff engineers should think about this problem?
Yeah, no, it's a very good question. And because of that, I like another book called Normal Accidents by Charles Sparrow. I definitely
Do you have it on slides?
Yeah, of course.
Okay, cool. Let's show it.
Not a book itself. Yeah, I have a quote, but we can probably share. Book itself later. Yeah, it's called Normal Accidents. And you can see I'm more like when I'm talking about software system, I'm more curious about like how real world map to it, because actually in the real world people figured it out a while ago. But from what's Charles saying in the book, that's overall complexity and tight coupling in a system exactly producing system accident. And what's a system accident is? It's something which is happen at some point. Coming back to the levels. First level, you believe like accident will not happen. Level, you think like they may happen sometimes. It's like I was on this level for a while before my friend like told me otherwise. Like I was on level like accident will happen sometimes, and we need to prepare for it. So that's basically we're talking about this here. That's like some qualities of your system actually producing accidents by definition. Because what? Because our system is growing on complexity, and one best thing from like architect system perspective to deal with it is actually systematically look on complexity of your system and see how I can isolate components, how I can make them less tightly coupled with anything else, and how I can reduce this like interconnection between the system. Because when your complexity level going beyond some threshold, like none of the safety devices, nothing like procedures, nothing will prevent you from like hidden paths in the system to accident. And it's getting to like good number of actually patterns and techniques which people may use for like prevention. Like I'm not sure, starting from like properly configuring retries in your system. That's everyone would be surprised, but nobody configure retry properly. No one know what they retry. They don't think about it. They never was in situations that retry caused them a trouble. They think like I send requests, like most of the system doesn't have retries at all. Like I send request, I expect another system to be available. That's like exactly first level. Like we expect that other system which we depends on will be available.
But this is a very naive thing. So the first thing that you learn at any decent course on system architecture or software architecture or like advanced software engineering, like you name it, how do you call, is like, hey, another system will be down, and the first question you ask when you're integrating with another system is, what is your contract, what is your SLA? And they are saying like, well, 3 nines, 4 nines, and then you say, okay, I need to incorporate this thing. Like I know the story about the SLAs and that they get breached, but at least you understand that like you cannot expect another system to answer you with a reasonable answer every time. You need to incorporate a scenario that another service will be down. It will reply with 400. It will reply with 503, with anything. And what you're gonna do about it?
Sorry, you make me smile. Basically, road to the hell is made from assumptions. In our case, road to disaster made from assumption. And the assumption you're making here, that's person who is designing this system or this specific component is had this like system or like software architecture course.
Well, yeah, you mean this is naive as well.
Yeah, exactly. But if you will think how like a lot of startups, lot of companies are starting up, like you have a couple of engineers who need to deliver something. You need to you need to have a business value. You have a customers who will like drop from you if you're not doing something. Like people have usually very limited amount of mental capacity even to think about this stuff. And unless you have like rigid procedure which like helping people to think about it and helping them not to forget about this kind of, they forgetting. Because why? Just because like they busy with something else. And
Okay.
And yeah, I think like our job as like senior technical leaders helping people not to forget. Because
Okay. Wait a second. That's an interesting point. Like, I agree 100% that like when you start a company or a new project, you're like, okay, we need to build an MVP, we need to bring business value to the users. But once you start getting the users in, somebody should say, hey, what will happen if like we publish an advertisement tomorrow? Like, what happens with Coinbase? Do you remember this story with how do you call it, like World Cup or something like that, like
yeah,
huge.
some traffic storm, yeah.
Yeah. So what they did, like I really want to share the story. Like what they did, they prepared the advertisement and they put only the QR code in the advertisement at the World Cup. It's like, I don't know, 100 million people watching online, right? And everybody was, oh, okay, interesting thing. And they started scanning this QR code, which led to the Coinbase main page or sign up page, whatever. And they got down. Like they prepared, they spent a lot of money because like World Cup is very expensive from the advertisement perspective. And they didn't get anything from that because, the site was down. So somebody should think about it. Like if you load spikes, like what happens?
Yeah,
Can we handle it anyhow?
Somebody should think about it, and I bet I know reason for the story, because usually what's happened, like marketing has someone who prepared this stuff, who is not, you cannot expect them to be technically competent to this level.
Yeah,
And
of course. Of course you can, but you can expect them to ask questions.
Expectation of people asking questions, it's already like second level.
Okay.
They first need to go through the pain, then they will start the questions.
Okay. So I'm spoiled already with my expectations.
Oh yeah. Lot of us is like really spoiled when you get into reality. Like, holy, like why it's happened like this, and when you disassemble it, like okay, yeah, two people did not talk to each other. So I bet like prepared campaign, leadership know about this campaign, but nobody clicked that. Like hey, World Cup campaign will lead to the surge of the traffic, and it will get us down, because you know what? Like usually people don't think about what's going wrong. Like I'm not sure how it's happened in humans' brains, because we technically survived for like centuries as a human. So like we, from one perspective, we wired to avoid danger, but we are pretty bad of like thinking about possible dangers, which we did not experience before. We're like, yeah, no, nothing bad happened. We just not even thinking about it. And when we're excited, we're like, yeah, let's launch it. It will be cool. It will be awesome. Everyone like expecting huge returns out of it. And when people excited about the returns, they stop thinking about downside risk.
Yeah, it's usually other way around. It's like everybody is expecting a lot of traffic and then nobody comes.
That's fine. we just burned our marketing budget. But what can be done here? And you're totally right. The people who like, you cannot build your way of operations assuming that people will do right things. If you build in your system assuming that people will do right things, especially the people who doesn't have like whole expertise in it, you already in troubles. Like you already ask for trouble. So like my call of actions for everyone who's listening to us right now, think about like where you expect people around you to do right things right now in your system. And if like there is a couple of places like this, you probably need to think, okay, what's you gonna do when people will not do these right things. And what can be done? Basically, I like another person, Todd Collin, he's talking about also safety, more in a physical world, but his phrase usually about it, that's like resilience of your system and safety is not about absence of accidents. It's about presence of capacity to deal with them. And capacity can be in very different type of scenarios. Like in normal circumstances, our capacity is number of servers which we have. Yeah, we have traffic surge, we're getting more servers, or like we're able to scale up to it, and we deal with it. And you need to think, okay, where are the places in my system where I may need extra capacity? Like starting with servers, but usually troubles coming from mental capacity. Like what's happened when your system going down at 2 a.m. in the morning and someone need to recover it? Would they have a reasonable mental capacity to deal with complexity of the system?
Oh, sure. We're calling an SRE, a server restart engineer.
Yeah, but would they like remember where to find out documentation, how to do proper things?
No, exactly. But that's why we have playbooks, right? So we mandate the developers of the services to create the playbooks, at least with some commands or things. Like if you see this, do restart. If you see this thing, well, it's not a restart, call us. So
that's where you're building for lack of capacity. You basically building playbook, you giving extra mental capacity to the person who will execute it. They don't need to think anymore.
Yeah, exactly.
They can just like check this, and do the stuff which is outside of normal procedures. That's how like reaction on thermal event happening. For any thermal event, you have a playbook. You know how you migrating service out of affected zone. And the second thing, what's important for any disaster recovery procedure, I'm a skydiver here, and basically most important thing is the training. Like you cannot expect that people will remember these procedures after a certain amount of time. And I think like that would be like second big issue which people have with disaster recovery plans. Everyone fancy, everyone builds a disaster recovery plans. They put like playbooks, they put everything together. Incident arrive, people don't know where its playbooks is. People reading them but don't understand them. People trying to execute them, but some tooling in this playbook doesn't work. Because like something had changed it, or someone changed something, and this it's no longer working anymore.
Okay, so you're saying like we need proper house engineering. So we need to simulate the disasters, right? Like data center going down, and see what SREs or other assigned people are doing there.
At least once in a while, yeah. That's very good practice. Like the same Amazon and AWS had like game days very often, and this game days was like couple of scenarios of game days. Sometimes what they did, they get some particular services down and see how everyone else reacted on it. Sometimes they actually service going down, as you said, like people learning this thing, like service going down, we know it can go down, we like build our retry policy about it, we know how to handle it. But do you know how to handle when your network capacity get to 10%?
Of course not.
Basically, when it's like latency of responses growing, like so system which is responding to you, it's still operational, but it's taking too long for you to get response, and you starting failing on timeouts. Okay, sounds like Vladimir going to check something in his system after this discussion.
Yeah, definitely.
That's cool. But exactly, it's again about like capacity and like where capacity can go down, or like where you may need it and extra. And yeah, that's exactly what I'm saying. You sometimes need to do these tests. You sometimes need to run the tests. Sometimes you need to do disasters. Like all good old days, like when people had like disaster recovery plans very formalized. Yeah, it's had to be executed like every 6 months or so.
Okay, just to get people knowing what they're doing in the case of a disaster, and like making sure that all the tooling is working when it's like it is very similar to this fire trainings, right? So I think there are a lot of laws and rules about like every half a year or every year you have a simulation of a fireplace, and you might need to make sure that people are going through stairs, not through elevators. You make sure that they leave their belongings there. You make sure that there's
they know where the fire exit is located.
Yeah, fire exit. That the entrance for the fire trucks are not blocked by some stuff, and so on. So you're saying we should more look at the physical world for the disaster tactics and apply it to software systems.
People build it for decades, and like it's honestly and unfortunately, most of it was built with blood. Like
plane industry, like the whole set of rules for planes, like literally written with blood.
All of them like come from accidents. Like as skydiver, for example, I expected to be current on what I'm doing, like in 3 months. So basically, if I did not jump out of airplane 3 months in a row, like 3 months before, so that's exactly position I'm in. Like I'm not allowed to do solo myself or even go with a group. I will need to go with a coach. I will need someone who will like, okay, you know what you're doing, like you practice it. You have a person who actually checking you that you're safe enough and like will help you to recover if something will go wrong. And which was evolved over decades in the sport, and that's like what's preventing it from disasters. I honestly like skydiving from this perspective, because from risk management and from like introducing simple steps to prevent issues, like this sport come from like place where it was like super risky to the place where actually number of accidents is relatively low. They still happen, but on a percentage, it's very low. And like, for example, I'm reading safety bulletin every year, which people publishing and like, hey, for the last year, that's 10 incidents happened. And that's what we learned from these incidents. And that's what we
really? They literally have postmortems.
Yeah, of course they have postmortems.
No, I mean it's like people died, you know.
No, not even to this extent. Yeah, there is like usually it's like 2 or 3 fatalities in the United States every year.
Okay. How many people are doing skydiving? Like I am trying to understand the percentage. It's like less than 1,000%, or
it was like millions skydives in a year. So like
millions.
Percentage of accidents is very, very low. I think now the sport get to position where it's safer to go skydiving than go motorcycle on a road, and it's very close to probability to car crash.
Okay.
Well, which is like insane if you will think about it.
The probability of going into a car crash, depending on the city, depending on the country, of course, but it can be very high in unsafe places. So,
and that's another thing which people sometimes don't understand about risk. When I talking about skydiving, they're like, "Oh, that's super dangerous," and I'm like, "Actually, on statistically, you're in a car, the same level of danger." And they're like, but I'm doing it every day and it was fine for years. So, and I'm like,
it's like disaster. How you say it? Normal Deviance?
Normalization of Deviance. So
normalization of Deviance. Like, but I'm speeding every day and it's fine so far.
it was fine. It was fine. But so what we can do as industry and what we can do is like people who are responsible for software system. We also can read like top 10 disasters in industry for last year. There is actually an article about it.
Can you name them right now? Like, what is the top 3?
I think AWS was slightly down.
No, I mean the reasons.
Oh yeah, British Airways lost online system February 25. That was probably.
Well, I didn't know about that. Does it have any details there?
Okay.
How many people died?
No, nobody died, but I think last year, if I remember correctly, it was another air company. Like actually, last year, air companies was very famous for accidents. Like their system go down because of traffic surge, and one of them, who was Southwest, they lost all the Christmas flight, and for them, like booking system was not able to handle a load. Usually, like as you're asking, like what's the main issue? System not able to handle a load, which happened because
I lost your sound. No, I don't hear you. No. Can you switch the microphone?
Okay, you should hear me now.
Yeah, but the microphone is not very good.
Yeah, and yeah, this microphone is not that best, and I'm not sure what's happened with this one for sure. But that's live example for you about of presence of capacity. One microphone got down. Yeah, I have a shitty one, but I have it next to me.
Yeah, that's a good thing. Like some service is better than no service, indeed.
Yes, and sometimes actually we're trying to like strike for the best service in the case of accident. But really what you need sometimes, you need a shitty service, but it's to be working. Yeah, maybe it's not doing the best, but it's doing the job. And that would be like much better rather than like we don't have anything. And yeah, coming back to Southwest, it was a snowstorm which caused like a lot of rebooking, and system was not ready for rebooking, so it took people manually a lot of time to rebook. And basically what they end up with like this fleet of planes ready to fly, with set of pilots ready to fly, but they're not able to key people into the system because system is too slow. And what's happened next after it? Basically, they see like pilot not allowed to be on for some amount of time. So basically, like you cannot wake up at 8 a.m. and go flight later because you need to go sleep after like some amount of time. So basically, because pilot was waiting, pilot stopped like start getting on hold. So pilot was no longer able to fly, and they had another wave. So basically, they booked people to the flights, but flights cannot depart because of a pilot, and that's like snowstorm. Move it pretty quickly on this. And yeah, that was totally disaster, totally unexpected from multiple standpoints.
How to lose a lot of money just because your service cannot handle the loads.
Yeah, it's very easy, very easy.
Okay, so this is one example. Like the disaster happened because you just didn't plan for the load. Okay, anything else? Maybe the floods, the fires, the thunderstruck, anything like that. Any exotic,
I think
happened with the data center.
I honestly will start with like simple stuff, like people making mistakes, hardware is failure, as this microphone, which was perfectly fine for last year or so. Like why it's get down today? No idea, honestly. But yeah, faulty hardware, and some of that is basically if you're relying on hardware, if you're like, hey, that's one piece of hardware or one piece of something, it's critical for us. You're already in troubles. Sometimes we have incompatibilities between the systems. And what does it mean? That's in normal operations, like system working fine together. But for example, when one system increasing the load, another system like is not able to handle it, or I don't know. I had a system which I worked with, which had like throttling mechanism. It's after certain number of requests per second or per minute, it stopped responding to you. It was the prevention of a load on the system, which was like great, by the way, but I was totally unaware about it. So what's happened? And like your load of the system is like slightly going up. Like your system is growing, like you're getting more customers, you're getting everything, but your threshold from another system imposed is like static. And they collide in some like specific time. Like probably my best and most fun accident in my life, which we had to fix, happened on February 29, 2016. Do you know why I remember this date?
Because it was like a leap year.
Yep, because it was leap year and software was not able to handle leap year properly. And basically in our logic, we had...
Problem 2000, okay.
Not even 2000, I'm not sure what it is. But the problem was that some software was not able to handle like this date plus 1 year. And someone like in some system library created a code which was like literally changed a year to 1. And you guess what? It was not like February 21, 2017. This issue was sitting there for 4 years until like I was waked up at like 3 a.m. in the morning when business in Europe like kick off and like, hey, we cannot work with the system and nobody even understand why nothing working. And yeah, it took us probably an hour to figure out what's wrong with it, and another 3 hours to actually hot patch it pretty quickly.
Yeah, that's funny thing that I remember the same date because I had a car crash on that particular date. So
did your car crash because of February 29?
No, it was just not very skillful driver behind me trying to get ahead of me by another lane, and I was making a left turn and we collided. But yeah, that was a scary day, I suppose.
So sorry you had this experience, but that's highlighting us another type of root causes and disaster, like simple human errors. Someone misinterprets their abilities and they thought like it will be fine, I can handle it, and they was not able to handle it. Someone like, I don't know, was sleep deprived for last week, and unfortunately they was on call rotation, and when it's come to them to do like some regular procedure, they executed totally opposite procedure. Like Google number of cases when someone deleted production database. I bet none of these people who deleted their production databases was about to do this. And that's happened why? Because they was overstretched and they like mixed environment, they thought about something else, maybe they had a bad day or something, and they made a mistake, which is like lead to the huge disaster. And one can ask like, hey, what's one can do about a human being human? And we're like, yeah, we need to build a system for human who is human, for human who is not perfect. And basically, if your system allows someone to do crazy stuff and it will be fine, it will be no guardrails, yeah, you're in trouble. And because of that, like, none of us like this approval process or like some peer reviews, but sometimes they're very helpful. To do destructive things in the system, sometimes you need to do like peer review for it. And it's like, I can tell for AWS, it's helped to prevent tons of accidents. We never would know about how many, but that's simple thing. I know, like in some system, I even had like, please type this phrase here in a box before we will delete this resource. And phrase is not like copy pastable or something you need to like literally think it through while you was typing. And while you was typing, like, actually, should I do this? Like, what will happen after it? And phrase was like, yeah, I want to delete this resource and I understand all consequences of doing that.
I remember that it's like something in S3 when you're deleting a bucket. You need to write like I really want to delete a bucket name, so you need to construct it, and it's like that's pretty smart actually.
And and if you will think about it, it's very simple prevention, but which moved you from like flight syndrome or fight syndrome, which move your brain from like, oh, I need to do something, to the position of like, hey, I need to think about what I'm doing right now. And it's very powerful thing. So like prevention of human errors, it's a big deal.
But by making the human think.
Yeah, like sometimes we think, and we're not doing it very often, to be frank. So like build for it. Put into your architecture the places where like, hey, these people will not think what they're doing. How you can prevent it? Like huge fleet restarts. It was another accident a couple of years ago. Some company, they basically one person like kick off a restart of whole cluster, which like lead to lack of capacity, downgrade of service, tons of issues. Like why single person can do this without like any like peer review? Because nobody even thought about it. Nobody thought about any particular harmful actions when people can do which can cause it. Like another one, and also like we can be hacked, yeah, and someone can have unauthorized access with like particular reasons for it. So like building system in a way that's like even it's hacked and some of part of system compromised, it doesn't mean like whole system is compromised.
Yeah,
it doesn't mean like they can do whatever they want when they get in.
Yeah, that's why we have separate networks. We have VPCs, we have RBAC models, and all that stuff, just to minimize the harmful, the blast area.
Yeah, demilitarization zone, like VPCs. That's what we did 15 years ago. But I think like now level of paranoia is kicking off a bit more. So basically, inside of VPC, you may have like a couple of services, right? And technically, what you want to do, you want to make sure that each of them, even they compromise it, cannot affect others significantly.
Yeah.
So basically, if like one compromise it, people not getting access to everything else. So you start building like, we call that like zero trust policy. So you not trusting by default, even like your peer services. You have authorization even with peer services because they may be compromised. If something compromised, you can shut down the access. Yeah, and it's cost you money, and every time we will get to decision like, hey, what amount of money we're ready to spend on it versus what amount of money we can lose. And like one of interesting example I can give to like for one system we designed disaster recovery for a system, and it was obvious discussion about like separate data centers, separate regions, separate everything, and we look on it and we look on like probability of this specific data center which we used as main to get down. We looked on the costs which we inquire, but like keeping another data center, and decision which was like probably would be surprised to many was like, no, we're not doing like even cold hot disaster recovery between data centers, because like as you said, like data center impose like some SLOs, and we know SLO, we know like what it will cost us to rebuild this infrastructure, like shifts particular traffic to another location if this data center will go down. And we're like, okay, that would be the plan, how we'll react to like thermal event there. And that's basically what we're losing in terms of money if this event will happen. And that's what we're losing in terms of reputation. And it was like basically SEO decision saying like, okay, between like spending, let's say 10 million on disaster recovery and losing 1 million for like this downtime potential which we can have, okay, I'm fine to lose this 1 million.
Yeah, yeah.
And it's a very hard decision, and sometimes it's very controversial, but you need to think about trade-offs you're doing.
Yeah, exactly. Yeah, in order to think about it, right, there's a book called Dancing with Beers. I don't remember. I think it's Tom DeMarco, author of that book. And he exactly lies down the whole risk thinking, right? So the calculation of probabilities, the cost you need to put in place, the prioritization of the risks, the tactics to manage the risks, etc., etc. It is pretty much a short book, but I totally recommend to read it to anybody who is like anywhere near disaster recovery, and like like at the point when you're like already able to build a simple service and put it to production. I think that's that's like the last possible moment you need to read this book.
Yeah, and actually, like, you need to read this book actually before you start building it. That's probably how you will save you tons of time in the future. So, like, be this person who in meta thought about, like, hey, how I will make recovery for this system, and like put for yourself like good cushion. So in 2 years from now, the one who will deal with disaster will say like, oh, that's cool that this person thought about it and did it. Speaking about risk management, there is another book called Grey Rhino, which is also talking more about like risk which is here and which will potentially destroy you if you're not dealing with it properly, but which we're ignoring. I also would recommend it to read together with a book from DeMarco. And yeah, start thinking about what's can go wrong before you start getting into it. So like my favorite advice in skydiving, like I'm thinking how I would land before I getting into the plane.
Yeah, that's a nice advice. Like we had a nice discussion. So I had several questions, but we didn't actually answer them. But that's fine. We can do that like another time, maybe when we meet. Right now, I want to ask, like, what is the most valuable lesson you learned about disaster recovery?
And basically, yeah, the most valuable lesson, we did not talk about third level from my friend. And basically, to repeat them, like first level, you're like, hey, disasters will not happen. Second level is like, yeah, disaster will happen, but it will happen sometimes. We need to prepare for it. And the third level, actually, the most exciting, like disasters happening right now. Something working not as expected right now. You probably did not notice it. And to build and to build the system that it's have like this excess amount of capacity to deal with disaster without making it a problem for your customers and for you, that's probably the most valuable lesson. So like, don't pretend like disaster event will happen sometimes in the future. Pretend it's happening right now, and build the system from this perspective. Like your cost part will push you in opposite direction, and you will need to be smart about it. Like, hey, what's level I'm comfortable with? But be ready that the disaster is already happened. Basically, this headset, that was here because of the reasons. And once in the like last 2 years, I think it's finally worked out. Sorry for terrible sound quality, but we was able to finish it.
Yeah, but that was a brilliant illustration to the talk. Like it's the best one which could happen. So yeah, thank you very much for this.
Yeah, it was not planned, but yeah, it was great.
Yeah. I should have stated that. Okay, cool. Thank you very much. So giving back your time, thanks a lot for the talk. I hope we will meet another time in the future with a better microphone, I suppose. And
I will fix this one.
Yeah, and we will talk about observability and back to the disaster recovery and anything that you could ask in the comments, like down below this video.
Yeah, and post in the comments what you would like to know, because I think we saw a lot of experience, so we would be happy to share it.
Yeah, another thing you can leave in the comments, like what is the most interesting disaster that you experienced in your professional career. That would be nice to discuss them.
Yeah, please share it. I'm collecting the stories of like spectacular failures. I love it.
Yeah, that's great. Okay.